Welcome to my YouTube channel. This is a first class for those students who are preparing NEET JEE exam. In the first class, I want to tell one thing, that we are focusing only on the formula and how to solve the problem using the formula and the trick. We are not focusing on the theory part of the physics. So the first chapter is a current electricity. The formula is I equal to Q by T, that is the rate flow of charge. Here E equal to 1.6 into 10 to the power minus 19 coulomb, and Q is equal to N is the number of the electron into E. And the second relationship is I equal to NEAVD, where VD is the drift velocity, A is the cross sectional area of the conductor, N is the number of electrons. Now using this relation, we can find out the relationship between the current density and the drift velocity. J equal to I by A, and the A term will be cancelled. In the last we get J equal to NEVD. Now third relationship is the relationship between the electric field relaxation time and the drift velocity. The drift velocity is equal to minus E capital E tau by M, where tau is the relaxation time, E is the electric field. Okay, now we know that from the potential gradient formula E equal to V by L, so the formula changed to minus E V tau by ml. Now when we are writing only the magnitude portion, then Vd equal to E V tau by ml. Rearranging the term, that is writing the Vd in terms of current, so I equal to NEA equal to EV tau by ml. Here we want to find out the V by I ratio, which is equal to, take the I term on this side and the remaining term on that side. So V by I equal to M upon N E square tau L by A. So R equal to rho L by A, and rho is equal to M N E square tau, where rho is a resistivity. Okay, so this is the main formula for the problem solving. Okay, now using this formula, so this is the main formula of this chapter, current electricity. Now using this formula, we have solved some problems. The first problem is the number density of free electron in a copper is nearly 8 into 10 to the power 28 inverse meter cube. A copper wire has its area of cross section 2 into 10 to the power minus 6 meters square and is carrying a current of 3.2 ampere. The drift velocity, the drift speed of the electron is, so we have to find the drift speed. What is given? N is given 8 into 10 to the power 28 meter minus 3. Cross sectional area given A is equal to 2 into 10 to the power minus 6 meter square, and the current is given I equal to 3.2 ampere. So what is the relationship? Here we have write the relationship I equal to NEAVD. So I equal to NEAVD, and we have to find the drift speed. So Vd is equal to I upon NEA. Put all the value of this into this formula. I is 3.2 ampere upon N is 8 into 10 to the power 28. Okay, area is 2 into 10 to the power minus 26, and what is electron? The charge on the electron is 1.6 into 10 to the power minus 19 coulomb. So Vd is equal to 3.2 upon 8 to the 16 into 1.6. Now solve the power. So So 10 to the power 28 minus 26 minus 90. Okay, so 3.2 upon 16, 1.6, and this will be 19.6, and this will be equal to 25. So 28 minus 25 will be equal to 10 to the power 3, and this will be equal to 10 to the power minus 3. So this point will be cancelled. 16 to the 32, 2 upon 8. So 1 upon 8 into 10 to the power minus 3. The answer is given 10 to the power 6 meter per second. Okay. So the answer will be 1 into 10 to the power 8 minus 3, and the option this will be the minus 6. Sorry, this will be the minus 6 meter per second. So answer will come into 10 to the power minus 6. So we have solved 1 into 10 to the power 8. So this will be 0.125 into 10 to the power minus 3 and 125 into 10 to the power 6 meter per second. This is our answer. So final answer will be 125 into 10 to the power minus 6 meter per second. Okay. So the second problem is, in a metallic conductor, under the effect of applied electric field, the free electron of the conductor drift from the higher potential to lower potential, move in the curved path from the lower potential to higher potential, move with a uniform velocity throughout from lower to higher potential, move in the straight line path in the same direction. तो इसमें आप लोग देखिए कि सपोज करिए हम लोग एक कंडक्टर लिए हैं, ठीक है, और कंडक्टर को हम लोग क्या कह रहा है, अंडर द इलेक्ट्रिक फील्ड, तो हम लोग एक सोर्स से या एक बैटरी से कनेक्ट कर लेंगे। तो जैसे हम लोग कनेक्ट कर लेंगे, इस फील्ड के कारण इलेक्ट्रॉन का मूवमेंट होगा। तो इलेक्ट्रॉन स्ट्रेट पाथ में तो चलेंगे नहीं, इलेक्ट्रॉन का मूवमेंट ऐसे होगा कि ये आपस में कोलिजन भी करेंगे, पर इनकी जो एवरेज वेलोसिटी होगी वो क्या होगी, कांस्टेंट होगी। तो कोलिजन करेंगे तो ये कौन सा पाथ फॉलो करेंगे, कर्व पाथ। और सेकेंड चीज़ ये है कि इलेक्ट्रॉन हमेशा फ्लो करेंगे लो टू हाई पोटेंशियल, क्योंकि करंट कैसे फ्लो होती है, पॉजिटिव टू नेगेटिव टर्मिनल फ्लो होती है। तो इलेक्ट्रॉन की डायरेक्शन जो होगी वो हमेशा फ्लो टू हाई होगी, दैट इज नेगेटिव टू पॉजिटिव टर्मिनल. Okay, so the answer will be move in a curved path from lower to higher potential. This will be the correct answer. Here I have mentioned that in which year this question is asked. Okay, in the previous example this is also mentioned that this question will come in JEE mains in the second shift in 2023. Okay. The third, a current of 2 milliampere flow through a wire of cross-section area 25 millimeter square. The number of free electron in a cubic meter are. The drift velocity of the electron is 10 to the power minus 6 meter per second. So again we have to find out the drift velocity. So what is given? Answer given that what is given? N is given. The number of free electron 2 into 10 to the power 28 and the cross section area. Cross section area is given a 25 millimeter square. Here the unit conversion is very important. The area should be in the meter as answer is given in the meter per second. Change the millimeter into the मीटर, तो 25 इंटू 1 मिलीमीटर बराबर 10 की पावर माइनस 3 मीटर. So this will be equal to, as there is a square, so this will be equal to minus 6 meter square. So we have to find drift velocity. The Vd is equal to, using the formula of first problem, and EA. So what is, sorry, Vd is equal to I upon and EA. The current is also given, I is equal to 2 ampere. The current is also given, I is equal to 2 ampere. So solve this. 2 ampere upon and 2 into 10 to the power 28, electron 1.6 into 10 to the power minus 19, and the area is 25 into 10 to the power minus 6 meter square. So 2 and 2 will be cancelled. Here minus 19 minus 6 will be 25, and this will be 28. So 28 minus 25 will be 10 to the power 3. So 1 upon 1.6 into 10 to the power 25 into 25 into 10 to the power 3. Solving it. So 25 into 16, it will be come to 400. So 10 divided by 400 into 10 to the power minus 3, and this will be cancelled out, and the answer will be 0.02 0.0 into 10 to the power minus 3, or 24 into 10 to the power minus 6 meter per second. So answer will be 24 into 10 to the power minus 6 meter per second. So the final answer is 24. Okay. Now come to, we have solved the fourth problem. Here the charge flowing in a conductor charges with the time s q of t equal to alpha t minus beta t square plus gamma t cube, where alpha, beta, gamma are the constants. The minimum value of current is, see, for finding the minimum value, first we know that I बराबर instantaneous I बराबर is equal to dq by dt. When we have to find out the minimum value, we have differentiate I with respect to time and keeping it equal to 0. Here, from here we have find t equal to t naught, the minimum value of time, and putting this minimum value into di by dt, we find out the minimum value of time. So let's solve this problem. This is a new problem for the student. So I बराबर dq by dt. Here q is given, d by dt. What is q? Q is alpha t minus dt square, alpha t minus dt square plus gamma t cube. So it will become to alpha minus 2 beta t plus 3 gamma t square. Okay, so the I comes to what is I comes to alpha minus 2 beta t alpha di by dt. So I come to alpha minus 2 beta t alpha minus 2 beta t plus 3 gamma t square. Let me check the value that I am writing it. So the i's come to from the formula di by dq by dt. This will come to alpha minus 2 beta t plus 3 gamma t square. Now again differentiate it di by dt. This will be equal to 0 minus 2 beta plus 3 into 2 into gamma t, and equating this equal to 0. So 2 beta is equal to 6 gamma t, and the t will be 2 beta by 6. Okay, now we know that I बराबर alpha minus 2 beta t plus 3 gamma square t square, and di by dt is equal to 0, and from this we get t equal to 2 beta by 6. Okay, now we have put this value into this equation and we find out the minimum value of I. So put this and we find out the minimum value alpha minus 2 beta by 6 plus 3 gamma 3 beta by 6 whole square. So find out the final value of I and comment the answer in the comment section. Okay, and if you have any doubt regarding the problem, please comment and tell me. In the next class I will comes to more problem with the more trick. Okay, so this is the formula, and from the formula we have solved the fourth problem. In the next class we will solve the more problem. Okay, thank you, and please subscribe and like my channel.